Well, hello everyone. It seems like it's been such a long time since I've done a lesson in a while. I am sitting out on my porch, beautiful sunny day on a Saturday afternoon. I'm getting ready to do the 2 videos for our next unit. So lesson 3.4 is the first lesson, lesson number 1, over solving 3x3 systems. We're going to spend 2 weeks doing this, which is only 4 days in class, 5 days outside of class. Well, I should say 6 days outside of class. And then the test will be the Monday and Tuesday of November 2nd and 3rd. So quick stuff. So I need you to, outside of class, make sure that you are watching the videos and doing some homework. You need to practice these. Okay, so we are going to use elimination to solve our first system that has 3 equations with 3 unknowns. So we call it a 3x3. The 3x3 kind of comes in when we do matrices and use Cramer's rule. And we find the determinant is 9 elements inside the matrix bars, and it's called a 3 rows by 3 columns. So the first thing we're going to do is we're going to number the equations 1, 2, and 3. We're going to select 2 of the equations to eliminate a variable, and the result of this would be equation 4. Then we're going to select 2 other equations, eliminate the same variable, and this will be equation 5. Now, if you look at equation 4 and 5, then we're going to do exactly what we just did last unit. You can use substitution or elimination, and you can solve for the first variable, plug it back into equations 4 and 5, and that will give you the second variable, and then take both those answers and go back up to one of the original equations, 1, 2, or 3, and that will find our third variable. Therefore, you will get an ordered triple. Make sure you put it in alphabetical order. Okay, so here we go. We're going to number our equations. So this is number 1, 2, and 3. And I usually circle mine because we're going to do some operations with them. So the equation is in a circle, but the operation that we do to it, we don't need to put a circle around. Probably on your paper, make sure you indicate which way you're going. So I'm going to go this way. And I'm going to choose to get rid of my y's. Okay, and the reason I like my y's, if you notice, there is 2 y variables that have a 1 in front of it, which makes it very easy to eliminate. The x and the z, there's also 1 of each of those, so they'll be fine. But we're going to go ahead and go with y right now. So I am going to take my first equation, and I'm going to multiply it by 2. And when I do that, I'm going to add it to equation 2. Okay? So therefore, my first equation multiplied by 2 is 2x minus 2y minus 2z. Oh, see, we gotta go back. Need an eraser. Let me just go back and redo that. Okay, I forgot to multiply it by 2, so it's minus 4z. And then that equals negative 12. So let's double check. 2x minus 2y minus 4z equals negative 12. That's correct. Now I'm going to add it to 2, so I'm just going to really write 2 just right underneath here. And if you notice, the y's are going to disappear. You also notice there's no z's, so I'm just going to leave a blank and bring my negative 25 over. Okay, so let's kind of slide this up a little bit. Okay, so when we do that, then we're going to add these 2 down. We get 5x. The y's drop out. I got to bring my 4z down. And this is going to equal negative 37. And we're going to call this equation 4. And I'm actually going to switch the color. Okay? Okay, so now what we're going to do is we're going to look back up at our 3 original equations. We're going to pick 2 other equations. So I can't pick 1 and 2. I can pick 1 and 3. And I can pick 2 and 3. But we got to eliminate the same exact variables. So we're going to eliminate y. And I'm going to choose 2 and 3. So we're going to come this way. Let me get rid of that. There we go. Okay, so we're going to come this way, and we're going to do 2 and 3. So if I look at 2, 2 has got the 2 in front of the y. The 3 has the 1 in front of the y, but they're both positive. So I'm going to take equation 3 and multiply by negative 2. And then I'm going to add it to equation 2. Okay, so we're going to multiply equation 3 by negative 2 first. So I get 8x minus 2y plus 2z, and that equals negative 24. Okay, so 8x minus 2y plus 2z equals negative 24. I multiplied everything by 2. I'm going to recopy down my equation 2. Remember, we're going to leave a space for the z because there's nothing there. And we're going to put our negative 25 over here. Okay, we're going to draw the line. And we're going to add down, I get 11x. The y's cancel. Are going to bring down my 2z. And that equals negative 49. Okay, and we are going to call this equation 5. Okay, now, one thing I like to do is I like to have my equation 4 and my equation 5 next to each other. So we get this. Make sure you copy it right. 11x plus 2z equals negative 49. Okay, so now we're back to what we did before October break. So we decide if we want to get rid of x. If we want to get rid of x, we want to deal with a 55 in front of the x. If we want to get rid of z, we can keep the negative 4, and then we have to change the 2z to a positive 4. So I think that'll be the easiest thing to do. I'm going to switch colors so you can kind of see what we're doing here. So I am going to take equation 5, and I'm going to multiply it by 2, and then I'm going to add it to 4. Okay, so I have equation 5, which is this one. We're going to multiply by 2. So we're going to get 22x plus 4z equals negative 98. And then we're going to recopy 4 down. So I get 5x minus 4z equals negative 37. Okay, so if I draw my line, I'm going to move this up just a little bit further. Okay, and we draw our line and add straight down. We're going to get 27x equals, the z's actually cancel out, and it looks like it's negative 135. So I get z, oh, that's an x, let's go back. I get x equals negative 5. And then I usually put a square around it so I know what I got. Okay, now here's the part that people get tripped up on. I have one variable, so therefore I need to go to the equations that have 2 variables, not 3 variables in them. Substitute the x in, find out my other variable. Well, if you notice, we want to go back to 4 and 5. Okay, and I'm going to switch back to red here. So you can pick 4 or 5. I'm just going to go ahead and pick number 5. So if I go to 5, so I come up here. So we're going to put 11 times negative 5 plus 2z equals negative 49. So I get negative 55 plus 2z is negative 49. I'm going to add 55, so I get 2z equals, let's see, I didn't do it that way on my paper, so we got 55 minus 49 is that 6. And then z equals 3. So now I have 2 variables. I have x and z. And so I am going to go, doesn't matter, we can go back up to the top. Why don't I move this down so we can look? Go back up to the top. Number 1 looks pretty easy, so why don't we just plug them into number 1, okay? Okay, so I'm going to recopy my number 1. And let's just go ahead and do that in black. Okay, so number 1 is x minus y minus 2z equals 6. Okay, so we're going to substitute x in. I got negative 5. We don't know why. Minus 2 times z, but z is 3, and that equals 6. Okay, so we have negative 5 minus y minus 6 equals 6. Well, that gives me negative y minus 11 equals 6. Add 11, I get an error. Holy Moses, what did I do wrong? Let's go back. Z is 3, Z is negative 5. Okay, so did I copy it wrong? Oh, negative. Oh, I did. Shoot, guys. You're not here. You can't tell me that. I did. It's negative 6. There it is. Okay. So then if I add 11, I get negative y equals 5. Y equals negative 5. My ordered triple then would be x, negative 5, y, negative 5, and 3. And if I look at my answers, I got negative 5, 3. We could also do a check. So like if you wanted to check it, you could check it with another one. So maybe even, I'd probably choose number 3 because 3 has all 3 variables in it. So you got negative 4, be negative 4 times x, and x is negative 5. And then we have plus y, and y would be a negative 5, so plus a negative 5. Then we have minus z, so minus 3, and we need to check if that's 12. And if we type that in, you get 20 minus 8, which is 12. So that checks. So I know that my answer, let's see a highlighter, let's highlight in green. My answer right here is correct. Okay, so that's the first example. Okay, the next example is example 2. So let's just scroll up a little bit further. Okay, and we're going to do this again. So the very first thing we need to do is make sure we number our equations. When you go through and you start doing these, and you don't number them, and you don't tell me what you do, and be neat in your work, it's much easier on paper than it is on this little screen. I can't write as small. So you need to do that. In order for us to find your error, we got to know what you did, and we need to get practice of writing this down. Okay, so let's go ahead and number our problems. We'll just start off with green. Okay, so this is 1, 2, and 3. Okay, so when I look here, I got an x has a leading coefficient of 1. Z looks kind of nice, though. If you look at z, the z's, there's one positive and one negative, so that would be okay. My answer key I have here, so I don't have to look up all the numbers and get calculators out. I'm going to get rid of x. So we're going to go ahead and get rid of x. So that means I got to take equation 2. Let's back that up. We're going to add equation 2, so let's back that up one more time. So we're going to take equation 1, and we're going to multiply it by 2. And then we're going to add it to equation 2. Notice that I wrote that a little bit differently than I did before. So equation 1 multiplied by 2 is 2x plus 6y minus 2z equals 1. Then we're going to just add it to equation 2, so I'm just going to rewrite this equals 1. Now if you look here, we're going to get a gift. Yeah, it's not Christmas yet, but look. So you get negative z equals 2. We got an error. I did something you did. This is good. Let's go back up to equation 1 where I multiply by 2. Did you see I forgot to multiply the 1 by 2? So this should be a 2 here, which would give me a 3. There we go. I was like, what the heck? Okay, so let's go back and finish this. So I know z is negative 3. Okay, so that is my first answer. Now, we don't have an equation really 4 here. This actually is equation 4. So what we need to do now is we need to skip to getting equation 5. Okay, so we're going to pick 2 other equations, not 1 and 2. But we want to eliminate at least x. Since we aim to eliminate x, let's continue to eliminate x. Don't get confused. That y disappeared also. Okay, so let me go ahead and change. We'll go to blue. Okay, so now we're going to go to equation 1 and 3. And when we go to equation 1 and 3, we're going to eliminate x. So if we look at 1, I have to multiply 1 by a negative 3, and we're going to add it to equation 3. So if I multiply through by negative 3, I get negative 3 x minus 9y. Negative 3 would be plus 3z. And that equals 3. Ran out of room there. We multiply by negative 3, so it's actually negative 3. Let's double check. Multiply by negative 3, so negative 3x minus 9y plus 3z is negative 3. There we go. We're going to recopy 3, so I get 3x plus 5y minus 2z equals 4. Okay, we're going to add these together, and this is going to give me equation 5. X's drop out, I get negative 4y plus z equals 1. Negative 4y plus z equals 1 is what I got. Okay, so now I'm going to recopy z down. So I get z equals negative 3, which was equation 4. So if you notice here, we don't have to eliminate anything at all because we can just plug in z right there. Okay, so let me switch colors. So if we go to red, so if we plug in z right here, we're going to go this way. So we get negative 4y minus 3 equals 1. This is equation 5. So we get negative 4y equals 4, and I get y equals negative 1. So now I have two answers. Okay, so now we go back all the way up to the beginning. We have y and we have z. We have to find x. I'm just going to go ahead and put in equation 1. It just seems to be simple. Doesn't matter. Okay, so equation 1 is x plus 3y, and y is negative 1, minus z, well, z is negative 3, and we want to know that equals 1. Okay, so let me move this up a little bit. So we have x minus 3 plus 3, well, they cancel, and that equals 1, so x equals 1. My ordered triple is 1, negative 1, negative 3. And it looks like what I got on my answer key, but we definitely want to check it. Okay, and I got a little bit of room down here, so let's check it in yellow. Okay, so if I check it, we got to go back up to our original. Let's just pick number 3 since it has more numbers in it. So we're going to do our check. So we're going to get 3 times x. Well, x is 1, so 3 times 1. Plus 5 times y. Well, y is negative 1. Minus 2z, so minus 2 times negative 3, and that should equal 4. So let's look. 3 times 1 is 3. 5 times negative 1 is negative 5. So 3 minus 5 is negative 2. Negative 2 plus a positive 6 does equal 4. So I know I'm okay here, and my answer is correct. Okay, that is 2 3x3 systems solved by elimination and some substitution. Okay, so now, being in the honors class, you also are going to have story problems. So why don't we go ahead and let's push this up a little bit further. Let's read this story problem. We're going to have 3 equations. We're going to have x, y, and z, so we need to define what x, y, and z are going to represent. And then we need to set up our 3 equations, and then we need to solve for our answer. I hope I have enough room here. Okay, so if we read first, it says Billy's restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. Love daisies. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? So remember, we talked about money, and we had a money equation, we had a quantity equation. Well, this one also adds a comparison equation. So it's going to be 3 different. So our first one, x, I would say, would be the number of carnations. Y would equal the number of roses. And z would equal number of daisies. Okay, so we know, the first thing we know is that 200, let me put this in yellow, green, 200 flowers. So if we have 200 flowers, then we have x plus y plus z equals 200. Okay, and then we know that $1.50 each, roses $5.75, and daisies are $2.60 for a total of $5.89. So if we go through and we do this, then we know that we have $1.50 x plus $5.75 y plus $2.60 z equals 589.50. 50. Okay, then our third equation is a comparison equation. Our third equation actually compares, let's do yellow. Actually compares, we said they ordered mostly carnation, but 20 fewer roses than daisies. So we're comparing roses and daisies. Okay, so here's roses, and here's daisies. Okay, so if roses are 20 less than daisies, that means daisies have more, so it's heavier. So that means we want to add 20 to my rose side, and that will equal the number of daisies now. So here's a couple things that we can do. You can substitute y plus 20 in for each of the z's, and then you get an equation that have x and y in it, and then do elimination. You can move the z over and the 20 over, and then you can line them up and do exactly what we've been doing before. Okay, so since I'm going to continue this lesson, I want to do that. So let me undo all those arrows. Okay, then we want to put the plus 20 back. Okay, so let's rewrite this equation here. So we're going to go y minus z equals negative 20. And we're going to not worry about that. So there's equation 1, 2, and 3. Okay, so if we look here, if we look at 1 and 3, it looks like the z's cancel right away. So why don't we put 1 and 3 together and eliminate z. Okay, so we're going to come over here. So we're really just going to add 1 plus 3. So we're just going to rewrite them. And this will be equation 4. So we will get x plus 2y, because the z's are gone, equals 180. Okay. I'm looking here. This is looking a little off of what I did. I'm going to make sure I wrote everything down. I think I'll be okay because I just multiplied one of them by -1. Okay, we're going to go ahead and continue with this. Okay, so now I have equation 4. So now I need to do 2 other equations. And we need to eliminate z. So you got to do equation 2. So I think what we need to do is let's just do 1 or 2. How about 2 and 3? If we just do 2 and 3, since 3 already has a negative. Okay, so we're going to come this way. And how about we take equation 3 and we're going to multiply by 2.6. Okay, so we get 2.6y minus 2.6z equals negative 20 times 2.6. Negative 20 times 2.6. I got negative 52. Okay, so then we're going to add that to equation 2. So I'm just going to write equation 2 down. Okay, so when we do equation 2, I get 150 x plus 575y plus 260. Need to move this over a little bit. 260z equals 589.50. Okay, so we're going to add that together so I get $1.50x. Okay, I get 2.6, 5.75 plus 2.6 is 8.35. Y, those are gone, and that equals 589.50 minus 52, so 537.50. And this is equation 5. I'm going to rewrite 4 underneath it. So if we go back up and look at 4, 4 is x plus 2y. $180. Okay, hopefully this comes out okay. Okie doke. So now I have these two. Okay, well, how about I take equation 4 and we're going to multiply by, why don't we multiply it by negative 150? So we're going to go equation 4 by negative 1.5. So I get negative 1.5 OX. And I get 2 times negative 1.5, which is negative 3y. And that equals 180 times negative 1.5, which is negative 270. And I'm going to rewrite 5, which is 150x plus 8.35y equals 537.50. Hopefully, keep your fingers crossed. Okay, so we get 8.35 minus 3 should be a 5.35. Y equals 537.50 minus 270 is 267.50 divided by 5.35, yes, equals 50. And that's the answer I got. Yay, but I solved it a different way, so woohoo! Okay, so now we have to go to equation 4 and 5. We're going to plug in 50. Let me go to blue. Plug in 50, and I would say, oh, shoot, that's not what I want to do. Oh, it looks like we're on a new page. Look at that. It went down vertically on a new page. Okay, so what we're going to do now is we're going to go back to equate number 4, and we're going to put x plus 2 times 50, because y was 50, and that equals 180. So x equals 80. Okay. So now I have x and y. We're going to finish it out and go back to red. And we're going to go back to our original. I would probably go x number 1. X is 80 plus y is 50 plus z should equal 200 flowers. So that's 130 plus z equals 200. Z equals 70. So we should have 80, 50, 70 as our ordered pair. Now, if we want to check, though, then we need to go to a different one. We could plug it into 2. I'm not going to mess with that. I'm going to make sure negative y plus z. How about number 3? Negative y, the opposite of y would be negative 50 plus 70. Does that equal 20? And yes, it does. So I would assume we are correct. So we're just going to color that in, and it's 80, 50, and 20. Now, since it's a story problem, then you're going to need to put the wording with it. Okay, so if we put the wording with it, we're going to have 80 carnations, 50 roses, and 70 daisies. And that would be my answer. Okay, see you soon.